we ended with simplifying expressions. We're going to start looking at something that's very abstract and very mathematical. I couldn't think of a better word, but it's something that you will start to see as you get into higher and higher math classes, especially when you get into college. We're going to call these proofs. Many of you have been able to simplify things and solve equations and do all this stuff, but you haven't been able to prove it, or you haven't been asked to prove it. And so we're going to look at that. And this is where you would say, okay, the answer is 5. Prove it. And you would have to be able to justify everything you're doing. And if you get into any kind of a job, really any kind of a job at all, you're going to be asked to justify something. You will probably not be asked to simplify this expression and justify your work. Unless you're a math teacher, there's very little chance you're going to have to do this in your everyday life. However, if you want a raise, you can't just say to your boss, give me a raise. He's going to say, or she's going to say, why? Why should I give you more money? Prove it. Justify yourself. What can you provide? What evidence can you provide? Prove that you deserve to have more money. And if you are in a lot of different positions, you need to justify the things that you're doing. You can't just say, gimme, 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 or I think this is the way it should be. Just trust me. Although I said that in the last video, trust me. But you have to be able to justify yourself. And this is an organized, very methodical way of justifying things. And so even though you won't probably be asked to prove a mathematical expression ever, unless you're a math teacher, this type of thinking is really important. And it's very important that we start to train our brains to think in a logical, sequential way. So this is what's called a T-proof, because it's in the shape of a T. So a T-proof, and you're going to be making a T-proof. We're going to start with our expression, and we're going to name it 1. So the expression is 14x plus 4 parentheses 2 plus x, or 4 times the sum of 2 and x. How did we know we had that? That was given to us. So our justification for having that step, we were given the problem. What would we do next? If we were going to simplify this, what would you do next? Well, if we were going to do this problem, we'd have to get our x's together. We want to combine those like terms. But that x is stuck in the parentheses here. We can't just pull it out of the parentheses. We need to be able to get that parenthesis, or the x out of those parentheses so we can combine it with the 14x. And the only way we have to do that is with this distributive property that we talked about. The distributive property allows us to rewrite this as 4 times 2 plus 4 times x. And that 14x is still out there. So we can use that distributive property to get the x out of the parentheses so we can try and combine it with that 14x and simplify our expression. But we have to justify that. How can we do what we just did? We got from 1 to 2 somehow. And the only way we could do that is with the distributive property. And yes, you do have to write it all down. So how did we get from step 1 to step 2? We use the distributive property. Now, from there, we want to combine the 14x and the 4x, but they're not next to each other. So we can't just combine them together. The only way we can combine them together is if they're next to each other, and they're not. So we need to move things around so we can get the 14x and the 4x together. And so we'd have 14x plus 4x plus 4 times 2. How did we do that? I know we can, but how? And we do that by using the commutative property. So I'm going to write the commutative property. So we have the commutative property allows us to flip those addition problems around. So only with addition or multiplication can we do that. Now that they're next to each other, we can combine those like terms together. 14x plus 4x is going to give me 18x plus 4 times 2. You'll notice I still have that 4 times 2. I haven't done anything with that yet. So the only way we could do that is by combining like terms. All right, so we combined our like terms to get 18x. The last step then, we do need to actually do something with 4 times 2. And so we're going to get 18x plus 8. That's a lot of steps. A lot of things had to happen. We had to distribute. We had to use that associative, or the commutative property, excuse me. We had to combine our like terms. And then we had to multiply. And that last step then, we're just going to call multiplication. Now that I said it, I couldn't write it at the same time. Like chewing gum and walking, it doesn't work. Multiplication. And so we were able to use multiplication to get 4 times 2 to 8. And that was our final simplified version. We can't combine that any further. That's a lot of work. Justifying every step is a lot of work. What I'd like you to do is to use that model and try and write this out. I do want you to try, even if you get it wrong, at least you can get step 1. Step 1 is going to be the same no matter what. You write the problem down, it's given. But then try and follow this model and do a t-proof for this algebraic expression. I'm going to assume you paused it and tried it on your own. So, again, I'm going to start with rewriting the problem. And that's given to me. Do a lot of this in geometry. Okay, from there, I want to get, well, there's only one x, so I can't combine that with anything. However, we have those parentheses. And so I know I can break apart those parentheses. And I can use that distributive property to break the parentheses apart and distribute through the parentheses. So I'd get 6 times x minus 6 times 4 plus 9. And I'm going to use the distributive property to do that. Now, when I'm writing here, remember how difficult it is to use the smoothbore pen. So, distributive property. That third step, then, I want to combine. I can't combine 6x with anything, really. But I can combine the 6 times 4 and the 9. And so I can leave the 6x alone. I don't need to rearrange anything, but I should multiply my 6 times 4. So I've got 6 times 4, we get 24 plus 9. And that's multiplication. Multiplication. Now from there, 24 plus 9, you have to be very careful here. It's 6x minus 24 plus 9. We can't just put 24 plus 9. And some of you are thinking, why not? Because if we use our keep, change, change, if it's a subtraction problem, we should do keep, change, change. 6x minus 24 can be rewritten as 6x plus negative 24. It's a negative 24 plus 9, not a positive 24 plus 9. You're not going to get 33. We have to be very, very, very careful with minus signs. Minus signs and negatives will screw you up. You have to be careful. You have to slow down and be very meticulous with this. If you have a minus sign, do keep, change, change. Now you have 6x plus negative 24 plus 9. Now, that's not really a step. We're not going to include that because it's just a different way of thinking about that minus sign. It's not something we're actually doing. We're not moving things around. We're not combining things. We're not multiplying. We're looking at it in a different way. But with that, we've got negative 24 plus 9. So 6x minus, and if I find the difference, I'm going to get something. Again, it's late on a Friday. And so what am I going to get? 15 minus 15. Yes. And I did that using addition, actually, not subtraction. I did that using addition. And so that was step 4. Addition. And now we have it as simplified as we can get. All right. Ask questions. We'll try and do another one in class. But this T-proof stuff is hard because you really have to slow down and think about every single step that you're doing and show your work and know why you can do it. Be able to justify. Okay?